Ever wonder what keeps your smart thermostat clicking and massive factory machines running safely? It all comes down to two essential switches, the relay and the contactor. Let's break down the difference. First up, the electrical relay. Think of a relay as a digital world's helper. It uses a low-power control signal, usually 12 or 24 volt, to open or close a circuit, handling lower currents typically under 10 amps. On the flip side, the contactor is the heavy lifter. Designed specifically for heavy-duty industrial applications, contactors handle massive electrical loads and are built to manage thousands of amps safely. Size matters here. Relays are compact and designed to fit neatly onto printed circuit boards or tight control panels, while contactors are bulky, rugged, and built to withstand harsh industrial environments. When it comes to capacity, relays handle control circuits, managing signals and low-power devices. Contactors dominate power circuits, controlling massive motors, heating elements, and lighting grids. Looking inside a relay, you'll find a simple coil, an iron core, a spring, and delicate silver alloy contacts designed for clean, everyday switching without high arc risks. Contactors deal with a different beast, electrical arcs. Because they switch high power, they feature built-in arc chutes that instantly split, cool, and extinguish dangerous sparks when the circuit breaks. Where do you find them? Relays are everywhere in consumer electronics, home automation systems, automotive electronics, and delicate control boards. Contactors, meanwhile, live inside heavy industrial panels. They drive massive three-phase induction motors, industrial compressors, and heavy manufacturing assembly lines. For ultimate safety, contactors are frequently paired with thermal overload relays. This combination protects expensive industrial motors from overheating and phase loss. To sum it up, relays are for low power and control signals under 20 amps. Contactors are for high power, heavy loads, and industrial environments exceeding 100 amps. Both are vital heroes of electrical engineering, working together to keep automation safe and efficient. If you found this helpful, hit subscribe for more engineering breakdowns.